Hello folks, we'll see how dodgy today's memory card is. So having not recorded much of yesterday's Midland 2001, we need to record quite a lot of this because it's what the customer, what the potential customer, what the person who's emailed me needs to know. JWR M2, John Wolfe Racing. There were never any other sets. They did plan an M1 and an M3 and the Diplomat base station, but they never happened. So it's one of these. This is all I could find in our shelves. It's a Signal 1001 version, this. Just the same. So the JWR M2, that, the Lucas ACB888, the Icom ICB1050, nothing to do with the real Icom company. It could just as well be Calvin Klein. It means absolutely nothing. Some information on how to convert these to 10 meters, because this is what was happening to a lot of these. When they got dumped on the market at £19.99 new, people were usually failing to convert these to 10 meters and screwing them up. And it's mostly these that are on the market today, screwed up half-finished conversions. So that is useful information. It's also available as the SMC Oscar 2. So not the Cybernet Oscar 1 with the small meter, but just the same looking. These are exactly the same looking sets. And so that's 3. Then you've got the Murphy DS602 and the York JCB867, which are pretty similar circuits, but with a more conventional synthesizer. They use the LC7137 from Sanya to generate the channels, whereas these use a general purpose synthesizer, and it's the same circuit as used in the DNT, but it's a totally different board out of a different factory. So we're going to look inside this. We're going to look at some the good instruction books, very comprehensive, how to do SWR, component lists. It does come with a circuit diagram but no layouts, but it's all better than nothing. And at least we've got 2 of the 3 books. We should have got the SMC one, but I've not been able to find the file for years. So this is the 3 sources of information we have. There's nothing more. And these are one of those sets where when you buy a batch of scrap radios, you always end up with one. It's a unique pin minute. I can't even speak. Unique pin layout. So we're going to have to wire a mic specially for this. At the end of this demonstration, if we can get it to work, we'll be flogging it. So, Signal 1001. Oh, it's allegedly it is Cybernet standard. So is that true of the others? SMC Oscar 2 isn't listed. JWR pinout 1 and Icom, there's Lucas 888, that's shown as 1, and finally the Icom pin. What? Right, so it's standard Cybernet. Well, I'd forgotten that. Well, that saves me having to make up a special mic. So we've still got this on our bench. Well, only I don't know whether this is a failed conversion. I do not know what's in here. It's come in with a batch years ago, and it's coming off a shelf which I've had to blow some dust off this. I've not been on that shelf for 11 years. So the fact the speaker's unplugged could be a problem. So the first thing you're going to discover, and this hasn't been messed with by the looks of it, it shows that this is engineer designed, and the same applies with what I'm saying here with the Uniden, and that is a paper cut in doing those manuals. So let's zoom in. I'm going to put that still. I'm going to zoom in, especially if I do it on the right camera. We're going to do a lot more of this exploration than we normally do. So look at the wires which go down to the phase lock loop chip here, which is an MC145156, isn't it? 151. Let's get one of these here. Little 10 something or other. Right, so still with memory card problems, I'm trying to show you the colours of the wiring which follow the resistor colour code around the synthesizer, the Motorola MC145106. I've got my eye on the memory card. Bombs out after 20 seconds. So we've got brown, which is 1 in resistor colour code, red, which is 2, orange, which is 3, yellow, which is 4, green, which is 5, blue, which is 6, and violet, which is 7. Then we've got this red herring of a pink one. So the pink one disappears off to the channel selector board, so it goes to the left of the channel selector board. It's the only wire that goes there. The others go in resistor colour code sequence from right to left, except the N2. So we've got brown, red, orange, yellow, green, so that's our 5th one. And then we've got this red herring, where you'd expect the blue one to be next, followed by the violet, but it's the opposite way round. So as long as they're the wrong way, and so a lot of people trying to restore those go in the wrong way round. The other thing to show you is that the extension speaker socket, which often is going to be disconnected, you've got the red wire goes there to the right, you've got the yellow one goes there to the left, and then you've got a plain one there. The next thing's the high-low power switch, repurposed into something stupid usually, and you've got an orange wire which goes to the transmitter down there, and that orange wire is the one, just get this on the right angle for you, is that one there. That's the orange wire to the high-low power switch. The yellow wire, which I'll show you in a moment, and then the red wire is the centre one, which goes to this display board here. So orange, red, yellow from top to bottom. So the yellow one, which goes to low power, goes, as you'd guess, to the low power preset, which is here. So that's one of the yellow wires. I'm going to go through yellow wires because this person's got yellow wires off. Another yellow wire goes to this capacitor at the back. So you've got an electrolytic capacitor just there. That yellow wire ends up going here to that preset, which is the preset for the meter, RF meter. So that's one yellow wire. So we've covered the low power yellow wire, and we've covered this one, which goes from there to there. So that covers your yellow wires. Your speaker wires, the black one goes to quite near the back of the chassis there, and the red one in between the yellow and the black. So that's covered those. So we've got this plugged in with a Cybernet standard mic, and I've switched it on a second ago, and it kind of looks to be working. It might be set, which I've done in the past. Let's zoom out, still look at the record console, and it's still working. So let's see what we can do. Transmit. I'm going to better get a sheet of paper for this, write it down. Lost my clipboard. That's because I've covered in so many papers for this type of radio. So signal 1001. Signal 1001, it's the 21st of September 25. We're probably going to end up having to do this tomorrow along with the on the air test, because it's just I've wasted hours with memory cards. Mr. Chippy's actually been resoldering one of the memory cards, which a friend of ours found in a bin. It doesn't look to be compatible with this system. So we're going to transmit. We'll switch picture in picture on. There we go. And main meter. So we're on channel 20 and we have got 3.9 watts. I think it's probably a set I've done years ago. So 3.9 watts. And let's go through the channels. And we've got 3.4 watts on channel 40. And on channel 1. Oh, we've got 1.7. Perhaps it isn't one I've done, or it's starting to need doing again, which it's getting. So low power, let's see what we've got. And we've got 420 milliwatts. Our current consumption on full power is 1.26 amps. Seems a bit high to me. Deviation on this test set, wallow, is 3. We won't be doing the VCO. Frequency, this is where transmit and receive aren't interconnected. Let's go to the frequency counter. Frequency counter says 2779130, so that would be fine. 2779130. All we can do on receive is put it on what you expect this set to be on, because I say transmit and receive aren't interconnected on their frequency, so we'll guess that it's somewhere like where it should be for our initial readings. And we'll get this now plugged into the test gear. Incredibly, we're still recording. No point in me telling you that, because if we weren't, you wouldn't hear any of this and it'd be like yesterday's Midland. Right, it's over to the Synad meter. What have we got? For 12 dB we got 0.42. What dodginess have we got there? 0.42 microvolts. For 10 dB, still got 0.42. That doesn't sound right, does it? I think we've got to hold on to the chassis on this set. 0.47 in that case. And for 20 dB, 0.76. Squelch to full. I don't even think there's a preset for squelch. It's 100 microvolts, so it's right. Perhaps there is. I know it isn't on the Murphy, but the Murphy's not quite the same. And for minimum squelch, set threshold. There's a strange arrangement with RF gain and squelch. And when you adjust the squelch, it adjusts the RF gain. 0.33, which is excellent. Transmit meter is correct. Receive on channel 9. For S9 for 100 microvolts is correct. I think it's been done in the past. And they don't have PA. Right, so here we go. We've got to start by setting 10.24. So you need a frequency counter, and you're going to connect it to where? So we'll look at this circuit. Whereas between pin 3 and pin 4 is the crystal. I think we're going to be looking at pin 4 is probably ideal. Got to get to it. So pin 1, there's no handy test point, or is there? But there's a test point at 5. Let's see whether we can pick up a signal. We'll just put the frequency counter up. We'll try and use the one built into the test set. We'll switch the radio on. It doesn't have to be in. It just needs to be in whatever mode you want. We'll have it in receive. Well, I've got no power. Have I managed to disconnect it? Oh, we're on now. Whatever happened. Two, three, four. Well, let's try the little oscilloscope. Might even have a real probe on it. Yeah, it does. Need an earth from somewhere. Let's pick it up from chassis. Try that again. Incredibly, we're still recording. 1, 2, 3, 4, and we've got 10.2368. 10.2368. So we want that to be 10.24. That's a broken trimmer. How annoying! I've managed to break it. 10.2. This is a 10.24 adjustment. Except, obviously it isn't, so it must be the other pin. Did I say pin 3? Just try that point there again. It's not that, it's not that. Oh, what's that? So pin 3, let's try that. No, back to pin 4. Well, why wouldn't it adjust? Oh. I don't understand that. 10.2. Okay, we'll adjust it for maximum. Now we'll look at transmit. That's not what I was expecting. But we have maximised it. As long as we can get transmit and receive to work on the right frequency. So now we're going to go over to transmit, and it's going to be the right hand adjustment CT202. So I want 2779125, so that needs to come down. So it won't, will it? So that's as low as it's going to go, 79388. So we're going to have to just fiddle with this till we get to... You see, we're setting this... This isn't how it's done. This is going to make the receiver slightly lopsided. Anyway, what we do, I've got it on 79133. That'll do me as far as the frequency, but can we get the receive to match? Here we go. Not that I can hear anything. Right. Got dirty volume control, haven't we? That's the problem. It's so annoying. I'll see if I can clean it right now. Right, so well, no tone on. Signal generator to 2779125. Ramp up the volume. 100 microvolt signal, which is what we've got, S9 equivalent. This is where you need your second signal generator. So we'll plug in our second signal generator. Unplug the computer printer, which will say switch me off properly. And we've got this set for 10.695. And can you hear that musical note? Waggle the output. And adjust the receive reference, receive crystal. So it has gone on frequency. Because we've had to mess about with 10.24, I wasn't expecting that to go on frequency properly, but it has. So we've got transmit. Let's go back to transmit. 2779132. That's absolutely fine. We've got receive. We know is on frequency because we used that. So you need two signal generators, one on your frequency you want, 2779125, and the other on the IF of 10.695, and then you need to nullify the musical note to net it on frequency. So that's the receive on frequency. So we'll go back. Are we on the cyanide meter? Yes, we are. Go to that on the camera and see if we can get anything more out of the receiver, which is already working well. We'll start with the detector. I'll tell you what, I'll go to the oscilloscope. And the detector is the coil there with the wax in it. Mr. Wax has been around. There we go. That's definitely peak. And then we need to go through the rest of them, which have also been filled with wax. And what we're going to do is drop the signal. So let's hope we're recording. And what we didn't record was we did the detector, we've done the front end, we also did the IF, and I was able to see that best, not on the cyanide meter, but the actual meter on the front panel. We apparently seem to be still recording, don't know how long for. So that's the receiver tuned up. I'm going to go to the transmitter we're going to be looking at these coils, and up there, that is the VCO, so we're not going to touch that. So let's go into transmit, and we've got 4.4 watts currently. I've turned the soldering iron off, and I need that to undo the thing. I'm trying to be as quick as possible because this memory card could bomb out at any time. I think we'll be going to Argos first thing in the morning, buy one retail. So we want these centralising as we usually do. To detune and retune to the central peak. That was only just in the right place. Third one. That appears to be the peak. What have we got here? Is it a hexagonal one? I can't tell. And the last thing I want to do is to faff around when I've got this memory card only working for minutes at a time. Could be hexagonal. I can't even tell. That could have a slot in it. As if it has, I've not heated up enough, and the trouble is, it's in a polythene former, so the last thing we want is to heat it up and damage the former. I think we're going to assume that's in the correct position. I don't like to have to do that. But we are now at 4.4 watts, so I think we've cured the anomaly, which was that one back there. And our final one. That is too tight, but at least it's a Bakelite type of formula. Yep, that's moving. We'll tune that down now for 4 watts, which is there. So let's see what we've got on the other channels. I've got 4 watts on channel 40. I've got 4.1 on channel 1. I think that's as close as we're going to bother, especially given the very difficult time constraints with faulty memory card. So we've got 4.1, 4 watts, 4 watts. We want to go to low power and set that. So we've got 500 milliwatts currently. Let's turn that down. That's a bit dirty. Get the service all on that. There we go. We now have been so many hours trying to get this to the memory cards to work that we've no chance of doing an on the air test for this. We've got to do a President Grant tomorrow, so I don't think Mr. Chip is going to want to do 2 on the air tests, so they're going to go out of step with each other, unless of course we've got to order parts for that, which is quite possible. So transmit, we want the meter to read in the centre of the red zone on high power, and it's nearly there. It's the preset just there. That's now in the correct position. Receive, same kind of thing, 100 millivolts on the meter. We want to have it in the S9 position, it's just over, and it's the preset next to it, which is move that capacitor. There we go. So that's that done. Don't think we've got anything else. So let's hope we're recording, and What we didn't record was we did the detector, we've done the front end, we also did the IF, and I was able to see that best not on the silent meter but the actual meter on the front panel. We apparently seem to be still recording, don't know how long for. So that's the receiver tuned up. I'm going to go to the transmitter. We're going to be looking at these coils, and up there, that is the VCS. We're not going to touch that. So let's go into transmit, and we've got 4.4 watts currently. I've turned the soldering iron off, and I need that to undo the thing. I'm trying to be as quick as possible because this memory card could bomb out at any time. I think we'll be going to Argos first thing in the morning, buy one retail. So we want these centralising as we usually do. So detune and retune to the central peak. That was only just in the right place. Third one. That appears to be the peak. What have we got here? Is it a hexagonal one? I can't tell. And the last thing I want to do is to faff around when I've got this memory card only working for minutes at a time. Could be hexagonal. I can't even tell. That could have a slot in it. As if it has, I've not heated it up enough, and the trouble is, it's in a polythene former, so the last thing we want is to heat it up and damage the former. I think we're going to assume that's in the correct position. I don't like to have to do that. But we are now at 4.4 watts, so I think we've cured the anomaly, which was that one back there. And our final one. That is too tight, but at least it's a Bakelite type of formula. Yep, that's moving. We'll tune that down now for 4 watts, which is there. So let's see what we've got on the other channels. I've got 4 watts on channel 40. I've got 4.1 on channel 1. I think that's as close as we're going to bother, especially given the very difficult time constraints with faulty memory card. So we've got 4.1, 4 watts, 4 watts. We want to go to low power and set that. So we've got 500 milliwatts currently. Let's turn that down. That's a bit dirty. Get the service all on that. There we go. I've been so many hours trying to get this to the memory cards to work that we've no chance of doing an on the air test for this. We've got to do a President Grant tomorrow, so I don't think Mr. Chip is going to want to do 2 on the air tests, so they're going to go out of step with each other, unless of course we've got to order parts for that, which is quite possible. So transmit, we want the meter to read in the centre of the red zone on high power, and it's nearly there. It's the preset just there. That's now in the correct position. Receive, same kind of thing, 100 millivolts on the meter. We want to have it in the S9 position. It's just over, and it's the preset next to it, which is move that capacitor. There we go. So that's that done. Don't think we've got anything else. Okay, well, Mr. Chippy's got the background music very loud. I've done the deviation. It's the preset there, and it was indeed 3 kilohertz. I've now dropped it to 2.5 peak with a 2.2 average. So we are actually done. Gone through all the presets with you. I've gone through the coloured wires. We're just going to look at the receiver performance. Hopefully. What's intermittent? Right, signal generator. It's probably get a copyright strike with this racket. Right, let's try and do this quickly whilst the memory card works. 12 dB is now 0.35 microvolts. .35. Where's my signal gone again? We've got an iffy connection. I could really do without this happening when every second counts. Works better that way up. Right. Need to hold on to the chassis. dB, 0.61. 10 dB, 0.31. We're just about there. Transmit frequency and receive frequency a differ. I got it at 27,79132. Deviation is 2.2 to 2.5. It was 3. That was at full whack. So, squelch is going to be just the same. It's preset, and the best squelch is 140 microvolts at full, and for minimum, .65. So we've done it, we've shown the pictures, we've shown the colours of the wires, shown what needs to happen. I'll get this put back together and we'll see whether we've got enough memory card working to just flick through the channels with Mr. Chippy's background music on foreground mode. I'm just going to show this quickly so that you can look at how the things on the back, I don't know why we're not in camera 1 mode, but we should be. You can see how these are. Look at these points. Diode, resistor, these capacitors, look carefully, take a photograph, take a screenshot of how it should be, because so many of these are modified. Right, just to conclude, we're on the aerial now. Let's put the camera back to where it should be. 190, roger. What about calling through on that Midland yesterday and I got a rather sheepish 10-4? I bet when we turn the squelch up the RF goes down. Yeah, it does. See, it's got RF gain built into the squelch. Anyway, nobody on, so thanks for watching. A very disjointed video using a memory card that seems to work 2 minutes here and 8 minutes there. We'll get that sorted by tomorrow. We're doing President Grant's SSB set tomorrow. Goodness knows how we're going to fit in on the air testing now that we've lost the time. Thanks for watching the Signal 1001, which is the JWR M2, which is the Icom, nothing to do with real Icom 1050, and also the SMC Oscar 2.